So this is some of my references for this stuff that I just created on Pinterest. And I would like to stay with this low asset vibe so that we don't create too much unnecessary stuff. So the simulation works pretty much the same as it did before, with an exception that this is lower res than it done before. Or is it? Yeah, it is. It goes like this and then like this. Creates this nice rows. Super low resolution at this point, but as I said, this will be fine. One thing we need to fix right off the bat would be where I made the mistake last time, which is in this instancing process during the render. So because I was only checking the grain sims on still frames, it appeared to me that it looks okay. But apparently it wasn't okay at all, because the instancer was previously set to random, which basically assigns every grain of sand a random, one of random 4 random grain models out of these that we import here. And this would be alright. Okay, so this is an old save. Yeah, so I will get to do it again. Alright, so it gets every point gets a random one of 4 random models from the grains of sand. And that's cool and all, but the instancer, due to the random setting, does it every single frame. So what it ended up happening is that the simulation looks very flickery because every grain gets changed every frame, and that actually looked a little bit like this Fata Morgana desert, uh, like visual illusions, but it's technically very wrong and shouldn't be like that, so I fixed it, and this is how you do it. So basically we need to set this to name attribute. So this is the first thing, but because we actually did and bother and set up this thing which assigns every single of these points with a name out of the original grains. So every grain has a name in here. Let's go to geometry spreadsheet. So it's grain 0, grain 1, grain 2, grain 3. And that's cool and all. And you use the name and a noise to assign these simulation points with various names, like one of the 4 ones. Everyone gets a name. So like all of these are 0 and all of these are 3. And this is a proper way to do it, but I just did not utilize this last time. So what we need to do is go in here into this reference node, and actually this source name variable is good, so I will use it in all of them because it's I guess a better way of doing it with the source name. As you can see, all of our grains have disappeared, and that's because I named this grain wrong. In my files, the name is, I did not know that the the primitive path would use the USD name, so I named it with capital G, and that's wrong. But I've already fixed that, so I'll just change the name to grain with small g, and it will work with the source name in here. Yeah, so in this way we have a new way of attaching instances to points, and a better way that is actually more robust and it doesn't flicker, so that's good. And we can actually also go in here to my object and go in here and pin this viewport. So I could just go here and change the sim to high resolution one, and it should just update the and we have much more points. They look better and are shaded using these attributes. So everything is procedurally following up. Everyone gets a different grain of sand, and it's pretty good. So what can we do to make it look a little more like those references that we have? Yeah, this is what I'm talking about. The bulging of the sand around the stones, and then the stone would just fit in there somehow. So this is what I will try to fake somehow right now. Okay, so we have stones, and they are just imported in the render. If I manage to do this, I will work on the renderings. But let's see. So let's see the garden. So we have the same points here. And what's amazing about vellum and grains in general is that at the end of the day they are just particles. So let's do obj merge, and I would just merge in this rock. Let's close this, then stone, and do stone 1. Right, so this is this stone, and I would do add create maybe, or let's do attribute wrangle. And in this wrangle, let's say stone at, I'll say at f at stone equals 1.0. So we have stone attribute, which doesn't do anything. It's just a 1. But I would like to do attribute transfer and from this to this. And don't do anything, just transfer the stone. And I would like to make a visualizer for stone, and use a color. A ramped attribute. And this can go grayscale, let's say. Yeah. And this is probably just too big, so let's do distance threshold. Oh yeah. So I would do maybe this just a little bit. You can see the inside is empty, so that's kind of a problem maybe. But let's do it like this, and then do attribute blur so that it doesn't just get a 1 value, because right now if we look at the spreadsheet I think they are just getting, maybe use this after I deleted most of the attributes. This will be prettier to look at. So a stone, yeah, so they are getting a 1 or a 0, but they don't really get any blend. I could do blend here, and let's see, are they? No, they are still getting either 0 or 1. They don't, it doesn't interpolate anything, which is alright. We can do it in here. I'll do this and say stone. This is the attribute I want to blur, and blur it with, I think, yeah, proximity. Alright, so now we have it like this. Maybe we can even make it smaller, and with the blur of 10 steps it gets like this. And now I'd like to do attribute VOP, add it here. I'll say lift stone. We won't be lifting the stone, but we will try to lift the sand with the stone attribute. So in here I will bind stone. So that float attribute that we just created, and I would like to create maybe a vector to float and also float to vector. So I will split position into 3 components, into x, y, and z, and feed it back up, so nothing changes right now. But I will change just the y component, and I will add stone to it, and we'll see what happens. It will probably shoot up a lot, yeah. Well, that's too much, for sure. Maybe we can just get away with this. So let's multiply, and a parameter. Call it lift scale. Lift scale. And it initializes to 0, so our points are no longer lifted. But if I go a little bit, then it goes up. And that's pretty cool, I think. So let's do 0.9 maybe. Yeah, so that would probably look like this thing. Okay, that's actually going pretty well. Yeah, the points are getting lifted alright, but there is a little problem. Let's see render. How does it look here? So the difference is not really noticeable, or does it not work? It does work. I can see it in here. Let's save in case of a crash. Why is it so slow? Well, we do have a 140,000 points in here, so that's probably it. Okay, but the thing is that it does lift them up, but it's not enough. We have another thing here. We just turn on the reference. Yeah, this is the reference. As you can see, it first of all is like more bulky up here and down here, so the shape is not uniform, which could be done. But what's even more important is that the stone actually creates this velocity when it hits the sand, and it creates this this nice band around. So I will try to do that, and it should be pretty simple, I think. So let's go back here, turn on our visualizer, and yeah, let's do group, delete points, disable, enable bounding regions, and do bounding object. And into this bounding object we will slap the stone. But before doing that, I'll also transform just a little bit. I'll scale it up so it deletes a little more. 0.05. But we need to change the pivot, because right now the transformation happens there. So if I change the scale, it goes like this. We don't want that. We need to use the pivot transform and write CEX, which stands for H-script expression for centroid in the X, and then here CEY, and then for the last one CE, and now it scales from the centroid of the object, and do it like 0.5 or so. So original one is this big, and then this one is just a little bigger. And just blast them. Just blast the group delete. Pin it here and sense him. Disable this. And if I delete them here using the stone, maybe I can also control it by lifting it up a little bit. Maybe even more, because I can see the bending. Yeah, somewhat. Maybe lift it. Maybe let's go back to 0.1 and lift it a little less. Let's check with the render side of things. Oh, actually make a special camera just for checking this stone. Let's name it Stone Cam. So let's pin the Solaris viewport and control the lift maybe with 0.14. Boom. And let's see it through the stone cam. Control it. Zoom it in. Let's make it more flat. Zoom it even more. And now, with render view, right, it has some depth of field, like the lens fucks with us, so let's just delete it, disable it, and let's see how does it looks with high-res sim. Am I working with the high-res sim? That would explain a lot. Oh, so that was the high-res sim. This is super low-res sim. I can't see anything here. I would like to make this sim at least twice this, or like 3 times this many points. But okay, let's work with low res for now. But the point is, it does work. And if I wanted to change the shape of this, how could I do that? I could definitely just change the shape of the stone. And that would work. And that was probably the easiest way to do it. So if I would just transform it here, and let's actually delete this and copy this transform, because it already has this centroid thing done and I don't need to do it again. I would just reset it. So to make the banking, I will scale it on X and scale it at 0.2 maybe. And it will not change the actual stone because we source it from a different place. We are just molding this attribute. So this lifts it up, and then we delete the points. Deletion, and it's here. Let's actually change this attribute, but deletion can be just like it was. Let's do something crazy, like 0.3 or so. Okay, it's a lot, like too much. Maybe 0.2. And the deletion. So this is a low-res sim, right? Yeah, it's pretty cool that we can... Oh yeah, this looks much better, I think. Yeah, we have the banking, so it's a little more here and here than on the sides. It's absolutely procedural, so we can just change the sim versions and they are updated instantly, which is always lovely. So this can be the stone transform. I'll make a nice little, and let's call it stone transformation. And just for the sake of completeness, let's slap the other stone in here too. So stone 2. Get it in there. Let's just do it on it also, just like the same. And let's see if it makes any sense. It doesn't. So let's do it at the Z. And merge them here, and I think it should probably sorta kinda work for both of them. Pretty solid. This attribute color is not part of the stone thing, it's just the color, so let's not mix it with the rest. Okay, and the deletion. For the deletion we need to do this thing. Maybe we can just get away with a merge. Or maybe we can't, because it needs to be scaled on its own axis. Because if I would merge it here, like this, and put them in this transform, then this centroid equation that we used is no longer inside of this stone, it's inside of both of these stones, and their centroids happen to be here, so they will scale in a different way. That's why I need to use two different transforms for each, one here and one here, so that they are scaled independently. Then merge them and use them for the deletion bounding object, and in this way it will work. Pretty cool.